Carboxylic acids are another type of functional group that contain the carbonyl group. Now, unlike aldehydes and ketones, this carbonyl carbon is also bonded to a hydroxyl group. So that's how we recognize the carboxylic acid functional group. A carbonyl carbon bonded to a hydroxyl group. And that carbonyl carbon is also bonded to some R group. That R group could be hydrogen for the simplest carboxylic acid known as formic acid. Many times when we're writing the formula for carboxylic acids, we'll write the formula for the R group in the C, however many C's there are, then however many H's there are, and then we'll write COOH because this indicates the functional group of a carboxylic acid. Now, what is an acid? So an acid is any molecule that once it is dissolved in water will pop off an H plus ion. Now this H plus ion is known by biologists and by biochemists as the hydrogen ion, but to chemists it's known as a proton because that's really all that it is. Hydrogen has one proton, one electron, and hardly ever has any neutrons. So when it loses that electron to form the H plus, it really is just a proton, and it's very, very reactive. Now carboxylic acids are what are known as weak acids. They don't pop off too many hydrogen ions, but they do pop off some when they are dissolved. Also, a carboxylate ion is formed. When that hydrogen ion pops off, it leaves behind it the carboxylate ion, which has a negative charge, and it is just the rest of the carboxylic acid. Some common carboxylic acids that occur in our world are acetic acid, which is the acid that is found in vinegar. It has a very characteristic odor, and like all acids, it has a sour taste. In fact, anytime you taste something that is sour, that sourness is the result of an acid being present in that food. Now, if we take a look at the molecular structure and ball and stick model of acetic acid, we see that it has actually hydrogens on this R group, this methyl group. These hydrogens on the R group, in this case the methyl group, will never ever be acidic. These hydrogens will never pop off a carbon atom. It is the special characteristic of this carbonyl carbon bonded to the hydroxyl group that allows for this hydrogen to be acidic and pop off when it's dissolved. Another common carboxylic acid in our everyday life is citric acid. Citric acid is found in lemons, oranges, citrus fruit. It gives it that sour taste. And if you notice by looking at the ball and stick and molecular formula, there are actually 3 carboxylic acid groups on citric acid, and each one of these can pop off a proton or hydrogen ion.